Welcome to 10 minutes CS. 731 My Calendar 2. In today's problem, we have to implement a program to use as a calendar where we need to check that the events should not cause a triple booking. Yesterday's question was about double booking. That is, let's say an event is there and we are adding another event. There should not be any two events which are overlapping. That question was My Calendar 1. I will add the link for that question in the description. So, what is a triple booking? A triple booking happens when three events have some non-empty intersection. That means if there are two events and there occurs one more event, now we have these three events which have a common non-empty overlap. So, this will be counted as a triple booking. One thing to note here, like the yesterday's question, here also our end time is not counted in the event. So let's see, we have an event from 9 till 20 and then we have another event from 20 till 30. So the overlap as 20 won't be there and it will count as a single booking only, where the 20th time is counted within our 20 to 30 event, not in the 10 to 20. So we have to implement two functions, my calendar 2 and the boolean booking function, where we have to return true if we can add the event to the calendar and false, and in the false case we should not add the event to the calendar. We have given an example. First we initialize our calendar and try to book it. So 10 to 20 we are booking. So as we don't have anything in our calendar yet, so this will be a true case. Now 50 to 60, so this will be added. There is no overlap, so this will also be true. Now 20 to 40, so 10 till 40 will be there. We can see that there is an overlap, but this is just a double booking, not a triple one, so it will again be a true. Now 5 to 15, now 5 will be here and 15. As you can see at this point, there will be an overlap between 10 till 14, so this will be a triple booking. So hence it is a false case and we do not add this interval into our calendar. Similarly, we can go forth with 510 and 2555. Now, how should we go about this question? So what we can do is firstly we have to store all them in a sorted fashion. That thing is confirmed to check whether adding a new event will cause a triple booking. So at that time we need to check what all events are occurring in that interval. Hence we should have them in sorted fashion. Now for this sort of problems, we can use a generic algorithm which is line sweep. Now how should I come to this conclusion? Because as we see, all these events are like x-axis. Let's consider them over the x-axis and them as points. So this question is similar to finding the overlapping points on our x-axis such that the booking intervals are like the points range which we are marking. In this case, we can use a map, and that too a tree map. Why a tree map? Because tree map stores the keys in sorted way. So whenever we are adding a event, we should increment the value for our start. So let's say currently we don't have a key 10, we are adding the key 10, so we should increment its value to +1, and we should decrement the value for 20. Why? So when we will be traversing over the line, we can check when the event is getting end. So let's say we started from 0, we came till 10, we got a value of 1 now. So now we know from now onwards we have one event which is occurring. Now after that we came at 20, so we will decrement the value by 1. So at that time we know that the event has ended. So each time we will be adding +1 for the start and -1 for the end. And how will we check whether we have a triple booking? We can have a variable number of events occurring currently as 0, and we can run a for loop over our keys, and for each of them we can keep on adding the values in our number of events. So let's see, we come to 10, we incremented the value. That means we have one event which is occurring right now, and we come to 20, we will decrement the value. And whenever we see that this variable's value is equal to 3 or greater than equal to 3, this condition will only suffice here, because at this condition itself we have to return false. And when we are returning false, we should undo our changes to the map. So what does it means? Now let's say we have added +1 for the start of our event, so we should add -1 for our start of the event, and +1 for the end of the event. This will undo the changes. Now let's do a dry run. We have first we initialize our calendar, that is we create a map with key and value pairs. And now we come to our book function, that is 1020. Now we add 10 to our key and +1 and 20 -1. Now we will run a for loop over our keys, and we have a variable which is events, which denotes the number of events currently happening. And we come to our key 10, so events will be +1, and then we come to 20, our events is -1, so it becomes 0. So while performing the for loop, we didn't encounter any time the events were 3, so we will return true. Now we have 50, 60, so we will add 50 +1, 60 -1. We will again run a for loop, +1 for our events, -1 events will be 0, +1 events will be again 1, and -1 events is 0. Anytime your events didn't happen to be 3 or more than 3. So this will also be returning true. Now 10, 40. We will increment for 10, that is this will become 2, and 40 will be here -1. Now we will run a for loop. Our events is initially 0. Now this will be 2, then -1, so it is 1, -1 again, so 2 +1, -1 again, so 0, +1, so 1, and -1, so again 0. Anytime we didn't have events as 0, so this will also return us true. Now please have a closer look at this interval. So 5 we have a +1, and 15 we will have -1. Now we will run a for loop over our keys. Our events is initially 0, so we have a +1, it is 1, and we have another 10 which is 3. Now here we see the events is 3, so if our events is equals to 3, or we can have greater than equal to 3 also. So we should return false, but before returning false we should undo the changes for this one. So our map for 5 will be -1 and our map for 15 will be +1. And if anytime that doesn't happen, we have to return true. Now if you see, why did that happen? Because initially we had 10 to 20 and we had another one which was uh, 10 to 40, and we are trying to add another event which is 5 to 15. So 5 till 15. So as we can see, at this point we have a triple booking. That's why we got a false here. Now let's look at the code. The code is pretty simple after the try run. We just initialize our tree map. Then for each of the event, we add the event to our map by having +1, and for the end we add -1. Now we have a count which is same as number of events, and we run a for loop over our key set. We get the value for that key and we keep on adding it to our count variable. If anytime we have count greater than equal to 3 or equal to 3, we have to undo the changes and return false, else we have to return true. Let's analyze the time and space complexity for this. As we are using a tree map, in tree map the insertion takes log of n time, and we are running a for loop for all the keys in our map. In worst case, this can go up to O of n, where n is the number of events, and here then we are undoing the changes, that is also log n, but it occurs only once. So in worst case, the time complexity will be O of n plus big O of log n only, that is approximately equal to big O of n. And as we are using a tree map which can go at max to a total length of events, so that will also be O of n in this case. This is a generic template for all the line sweep algorithms. Can we do my calendar 1 using this approach? Yes, we can. The only change that we will have will be in this check. There we were checking for double booking, so hence the check will look like count equal to 2. In that case, we will be performing such actions.